An ecological study is a study design that uses group level or aggregate level data to figure out if there is a potential association between two variables. For example, let's say you want to figure out if women that eat more fat have a higher risk of breast cancer. Perhaps you have information about the average dietary fat intake per capita, as well as breast cancer rates in 10 different countries. You could plot this information on a graph with dietary fat intake on the x-axis and yearly incidence of breast cancer, which is the number of new cases of breast cancer in a year per 100,000 women, on the y-axis. In Japan, the dietary fat intake per capita is around 650 calories, and the incidence of breast cancer is 50 cases per 100,000 women. On the flip side, in the United States, the dietary fat intake per capita is around 1,400 calories, and the incidence of breast cancer is 235 cases per 100,000 women. The rest of the countries, Switzerland, Denmark, France, Norway, Australia, Spain, Hong Kong, and Romania, have an average fat intake and breast cancer rates somewhere between Japan and the US. Generally, we can see that the more fat a country consumes, the higher the rate of breast cancer is for that country. And at this point, we might conclude that eating more fat leads to breast cancer. The problem with this conclusion is that we only have information from the whole country, and we don't have information about each individual within that country. In fact, we might get very different results from a study that uses individual level data. For example, let's say you conduct a cohort study using individual level data from all 10 countries. Cohort studies look at individuals in a group who have a certain exposure, as well as individuals in a cohort who have not had that exposure, to compare their rates of a certain outcome in the future. So you could follow 500,000 individuals that have a high-fat diet, which are the exposed group, and 500,000 individuals that have a low-fat diet, the non-exposed group, for 10 years. After 10 years, let's say that 34,000 of the women in the high-fat group, or 7%, developed breast cancer, and 39,000 of the women in the low-fat group, or 8%, developed breast cancer. Since 7% and 8% are very similar, it's likely that there's actually no relationship between fat intake and breast cancer in these individuals. The results of an ecological study can be different from the results of a cohort study, simply because ecological studies use group-level data instead of individual-level data. In other words, we don't know if the individuals who ate more fat were the same ones that developed breast cancer. When group-level information is used to make assumptions about individuals, it's called the ecological fallacy. And it's the biggest problem with using ecological studies to find out if there's a causal relationship between two variables. As a result, ecological studies are typically used to make hypotheses about the relationship between two variables. But other study designs, like cohort studies or case control studies, have to be conducted in order to figure out if there's really a causal relationship. Ecological studies are particularly helpful when individual level data aren't available, like if the two variables have never been studied before, but you have a suspicion that they might be associated. They're a relatively quick and cheap way to look at many different associations, since many countries have information on a lot of different variables all in one place. Alright, as a quick recap. Ecological studies are a type of study design that uses group-level data to figure out if there's a potential association between two variables, like fat intake and breast cancer. Ecological studies, though, cannot make conclusions about causal relationships. And the biggest issue with ecological studies is when the group-level results are used to make conclusions about individuals, which is called the ecological fallacy. That said, it's important to verify the results of an ecological study with studies that use individual-level data, like cohort or case control studies. On the flip side, the main advantages of ecological studies is that they're inexpensive and they can look at many different relationships at once.